Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, good morning everyone. I'm Wolfram Schulte, and it's my pleasure to welcome Bertrand Meyer, who stayed with us for the last 3 weeks. He started with an outlook on concurrent programming, and he finishes with one on event-driven design and building proper abstractions. Thanks a lot, Bertrand, for coming by and exploring the topic with us.
Thank you very much, Wolfram. So I know it's a very bad idea for a speaker to start by apologizing, but I'll do it anyway. You'll probably be somewhat surprised or stunned at why I chose this particular topic, because it's actually, as I said in the abstract, so at least I was honest, I mentioned it in the abstract, that it's rather elementary stuff. So the reasons for doing the basic reason for doing this is that I think there's a need for more reflection on software architecture, on looking at the way we build our software to try for the best possible abstractions, meaning in the end the simplest designs. And I don't see that so much of this around these days. People are excited about all kinds of new complex mechanisms, but this kind of fundamental drive for simplicity, for the best possible architecture that will enable us to build simple programs, and meaning in particular programs that we can reason about, programs that we can change easily, programs that we can reuse, in the tradition of the great software engineering gurus from Dijkstra to Hoare, Weert, and others. I don't see that much of this tradition anymore, and I think in my own modest and humble way, modest, maybe not humble, I'm trying to stir interest in this. Now, as I said, it's pretty elementary, so I definitely hope that you will understand every single pixel on the slides and every single phoneme of what I say. So the general context is event-driven design, which is in particular applicable to graphical user interfaces. Graphical user interfaces are not the only application area, but they're the most obvious and the one which has really rekindled interest in the whole area. This is before. This is the way it used to be in the good old world when things were simple. So we had the need, of course, to read elements from the outside world. For example, here we have this nice lady who is, I assume, executing this program, and the program says read a number of lines. So from I initialized to 0, we want actually a number of characters, and by convention I'm assuming that the last character is going to be an enter. So as soon as there's an enter, then this is over. It's a very, very simple scheme, and basically the program is in control, right? It's the program that tells the user enter something now. So this was then, and this is now, with all kinds of things all over the place, and I didn't even show the entire screen. This is just the PowerPoint slide. This is, by the way, it's a reflective or a recursive slide, because it's PowerPoint editing this particular slide itself. So what's interesting here, what's different, is that there's all kinds of things that what can be done. In fact, it is the entire screen. So at any point, I can click anywhere, or I can right click, or I can drag. So there's lots of things I can do, and I, as a user, I'm in control. I might actually continue with PowerPoint, I might read my email, I might start a chat. So it's a completely different scheme, completely different mode of interaction in which the user is in control, right? The scheme is more, when a user presses this particular button or triggers that particular event, to use this terminology that we're going to use, then execute that action from my program. So it's a completely different scheme, and it needs new control structures. Another way to look at it, this is just, if you like, a visual metaphor. It doesn't fundamentally affect the discussion, but it helps me at least reason about this kind of situation, is to look at it as if it were one of these physics experiments where physicists bombard some little totally innocent screen with various particles with strange names ending like the names of Swiss villagers, and to see what's going to survive on the other side. So here's one that goes, and then the subscriber on the right is interested in that particular particle in our world, in that particular event, so it's going to do something about it. And then there's another one that comes, and the subscriber is going to execute another routine, and so on. There might be also some events in which no one is interested, right? It just goes out and in the ether, and no one catches it. So that's the overall scheme, and we can talk about publishers and subscribers. And I'm going to use this terminology as well. I don't think there's any difference between event-driven and publish-subscribe. So we're going to look into architectures to address this kind of situation with, in particular, the following concerns in the background. The scheme should be simple, should be easy to use, so you should be able to apply it to any publish-subscribe situation, GUI or not. The GUI example is just one example, but there might be many others. As much as possible, we would like to reuse rather than to redo. That is to say, if we can turn the solutions into APIs, into things that we can directly reuse from a library, this is better than having to redo it each time. At least this is something I will postulate. It's subject to discussion. Then, so we are going to try to keep the business, in the GUI case, in the GUI example, we're going to try to keep the business model and the GUI separate, where business model or just model denotes the actual application, what the system actually does, and the GUI denotes, of course, the interaction with users. So it's relatively easy to come up with a solution in which everything is intertwined, and that we don't want for all kinds of reasons that I don't think I need to justify. If we separate the two, we also will try to have as little glue code between the two as possible. I'll describe this on a later slide. And in general, we want to be able to keep track of what's going on. In particular, this is again the notion of the concern about simplicity, in particular for debugging. It's well known that as soon as we decouple events and the handling of events, meaning subscribers and publishers, debugging becomes harder, as in concurrent programming as well. And we also want to make it to make the architecture easy to change, the usual concerns of software engineering. So just for fun, since I started mentioning terminology, I'd like us to do together a little bit of Microsoftology. You know, there used to be Kremlinology, where people would decode the messages coming out of Moscow. And here it's a little bit the same. So you can accept a certain amount of provocation on my part, but we can just have a little fun. So the exercise which I'd like to do with you collectively is to decode Microsoft speak to understand in this particular piece of documentation, which comes from the .NET official documentation, when they, I assume it's in another building, mean event, and when they mean event type. So we are going to overline when it's event, underline when it's an event type, and when we don't know, we just cross it out. So events have the following properties. Okay, so far we don't know. The publisher determines when an event is raised. Is that any? Okay, first one, I'll help you, right? So it's, in this case, it's really an event, right? The subscribers determine what action is taken in response to the event. So is it really the event? It's the type, right? Actually, it would be very nice in a way to be able to subscribe to an event, to an event, right? For example, I'd like to subscribe to the event. Microsoft's stock has risen by at least 10% today. The problem is that I cannot react to this, I cannot subscribe to this event because the event has already occurred, right? So it's too late. So I can only subscribe to an event type. An event can have multiple subscribers. These are the types, right? A subscriber can handle multiple events from multiple publishers. It's probably also the types, right? Events that have no subscribers are never called. So if you know the .NET, I'm sure you all know the .NET model very well. This is something that between you and me, don't tell anyone, but it should never be there, right? This is what this is, to the extent I understand it, is an implementation optimization. What it really says is we have this list internally for every publisher of everyone who has subscribed to the corresponding event type. And if no one has subscribed, we're not going to go into the trouble of triggering the event because no one's interested. Like me, if no one had come into this room, I would not have started well, maybe I can talk to myself, but if I don't talk to myself, I'm not going to start the speech, right? So it's just an implementation optimization, right? It's compiler optimization. So whether this is relevant to the overall description of the mechanism as here is debatable. So I'm not going to continue. I'll let you, this is an exercise for tomorrow to finish underlying the various occurrences of event and event type appropriately. So, it's not the end of the world, but still, since we're talking about abstractions, we're talking about design, it seems to me that it's really important, and that's what I try to teach to my students, for example, to have the right terminology and the right abstractions, because the two go together. And an event, the event type of the guy is going to bang his fist on the table is really definitely not the same thing as this, which is an event. Sorry.
Arguably, implementation details like events have no subscribers are never called could be really relevant in that you can know whether you can afford to use a mechanism or not based upon some knowledge of its implementation.
Okay. Point taken. Yeah. Maybe I was too strong in saying that it's irrelevant. But at the very least, it should say event types. Okay. There's also the terminology observer. In fact, we're going to have, I think this slide is out of order. It doesn't matter. There's some other terminology like observer is also used for subscriber. And there's also sometimes listener, depending on which sense you rely on, auditory or visual. And instead of publisher, we also say observed. So I'm going to stick more or less to the publisher subscriber terminology. The kind of typical scenario that we're going to try to address is this. One of my classes has a routine which might be called, for example, your procedure, a method. The application has a GUI object known as OK button. And whenever the user clicks here, then we want to call your procedure. Now, the OK button is not such a good example. In fact, it might be better to have a map because the arguments are going to be important. In the case of an OK button, it doesn't matter what the H and the V were, but in a more general case, it might. And indeed, this is going to be one of the delicate aspects. An event is going to have, in the general case, arguments, and we want to be able to pass these arguments to the processing code. Yeah?
Sorry, small thinking. Back to event and
Yeah.
event type. In natural language, this is a norm. You say, this animal likes apples. Of course, you mean type apples. You don't mean like this particular apple.
So what was the example again?
This animal, say Yuri Gurevich, likes apples.
Uh-huh.
And this is definitely type apple, not...
Wait, but you said apples.
Okay, apple eating
Rice.
rice, right?
Yeah, but rice is a category. Then you would say this bowl of rice if you wanted an instance. Okay, what's the expression? Houston, you have liftoff. So liftoff is a general category, and you're interested in this particular liftoff. I'm trying to make up an example for you. Yeah.
But the point is that in general, in normal natural language,
Yeah.
we often don't distinguish between a thing and its type. Just a manner of speaking, otherwise it becomes too tedious.
Yeah, actually this has a name in traditional rhetoric. It's not metonymy, it's not metaphor. I think it's the synecdoche, but I'm not absolutely sure. I would have to look it up. But this kind of thing has a name in traditional rhetorical discourse. And indeed, you're correct. In ordinary language, often it is convenient to confuse a category for an instance or the other way around. But of course, when we start doing engineering, we need to be very careful. So this confusion that I was referring to is very similar to the confusion that you find in the less careful part of the object-oriented literature between objects and classes. You know, people will tell you your system should have an object employee. Well, that's not true, except if, you know, the particular employee, Yuri Gorevich, is so special that he needs to have a particular module in the Microsoft payroll program just for himself. But this is probably not what they mean. What they mean is there should be a class employee. So as long as the context is clear, no bad consequence can result. But in fact, often what happens is that, as in this example, the two exceptions, the two meanings are completely intertwined, and then it becomes very confusing. I mentioned glue code. So if we have the business model and for example, the GUI, in this specific example of event-driven programming for GUI design, then we might have some connection objects between the two, and a part of our goal is going to be to minimize not only the coupling between GUI and model, but also the size of any glue code that we put in between for fairly obvious reasons. Now, the general framework, the general conceptual framework to talk about these things these days is the model view controller pattern, which I'm just recalling very briefly here, proposed many years ago already, 30 years ago, which says that we actually have three basic types of objects in our structure. We have the model, typically there's only one. We have the view, of which there may be several, because we might have several presentations of the same information, and then in between we have the controller. And this is very convenient terminology to reason about these things. Okay, first solution to the general issue, the observer pattern. And everyone kind of knows the observer pattern. I've actually found that using this as an interview question and pushing people beyond, you know, just a general feel-good description of what it's about is good to distinguish those who really understand object-oriented techniques from the others. So the overall scheme is this. If we have a particular publisher, it will be represented by a class that inherits from an abstract class publisher, and same thing on the subscribers side. You all know this, so I'm going very quickly. On the publisher side, the key data structure, which is going to be secret, is this subscribe list, which is a list of the subscribers. And of course, we can have many publishers and many subscribers, all built through inheritance. The single arrow is inheritance, and the double arrow is the use relation, the client relation. Okay? And the publisher has procedures attach and detach to attach or remove a subscriber. The key procedure on the subscriber side is this thing called update, which is deferred, meaning abstract, meaning not implemented at the level of subscriber, and which will be implemented. I will use the term effected, meaning provided an implementation at the level of every particular subscriber. So this is the overall structure. The picture represents the list of subscribers subscribed. So when I want to subscribe, I'm going to execute this procedure subscribe, which is a kind of callback. I'm going to pass myself to the publisher to which I want to subscribe. So current is like this, or self. And attach is the procedure which is represented here, and which simply adds an element to the end of the subscribed list. So I ask the publisher to add me, and that's what it does. Okay. And yeah, this is useful to have selective export. And then on the publisher side, the key procedure is this one, publish, which is going to loop through our subscriber list. Here's a little animation of representing the operation of this procedure. We're going to go through the subscriber list, and then step by step, we are going to call update on every successive item. Okay, this is what this does. And of course, this is fundamentally dependent on mechanisms of dynamic binding, polymorphism and dynamic binding, because basically what we find in every successive element of the list may be a different kind of subscriber with each its specific version of update. So this is a beautiful illustration of object-oriented mechanisms, in particular polymorphism, genericity, and dynamic binding. So at each step, this is really the key operation here. At each step, we do subscribe.item.update. Subscribe is the list, item is the current element, and update is the update procedure, whichever one has been subscribed, so to speak, whichever one has been registered by the subscriber. So this is very, very elegant. It is very widely used. However, it is quite limited in its application for the following reasons. Some more serious, others more, if you like, aesthetic. Perhaps one of the most serious ones is that a subscriber in this scheme, in the basic scheme, can subscribe to at most one publisher. You have one update procedure, and that's the one that you provide. So if you want to subscribe to several events, you can do it, of course, but it's more complicated. You need to vary the scheme a lot. A related point, which is the last one on this list here, is that I didn't talk at all in this solution about arguments. And in practice, it can be quite tricky, in particular in a typed object-oriented language, to make sure that you pass the right arguments, like my horizontal and vertical coordinates in the original example. This also breaks any hope at reuse, because if you wanted to turn this into a reusable component, you would have to account for all possible kinds of event arguments, and that doesn't work. So this is the reason why this is a pattern and not a library component. It's that you have, even though the scheme is always the same, you have to kind of adapt it for every new use.
I have a question.
Yeah.
The first difficulty, is that because you want to process different events differently, or would the same difficulty exist even if you wanted to process all those different events in the same fashion?
It's a good point. If you wanted to process all in the same fashion, then I guess it would work. Yeah.
Okay.
Yeah. But usually you don't. Yeah. But yeah, good point. More aesthetic criticism, if you like. The subscriber knows about the publisher. Okay. So this is sometimes reasonable, sometimes not. So sometimes it's okay to know exactly whose events you're subscribing to. Sometimes it's better to have one more level of intermediation, so to speak, where you are getting events, but you don't have to know who is triggering those events. Internally, this is purely aesthetic. Maybe no one else bothers about this, but this subscribe list shocks me a little bit. The fact that a publisher, like a GUI library, Windows Forum or Swing or whatever, this object, not the class itself, but the object has to have this list of subscribers. And the result of all these points is that in the end, it's not reusable. It's something that you must code anew for each application with always almost the same thing, but not quite. So we're going to try to do better. And the better approach, okay, I have to demonstrate it is better. The newer approach is common to many frameworks that you find these days, although people still widely use observers. I would say, by the way, just to prepare a little bit what's coming, that if you're in a language like C# or like Eiffel with the mechanisms like delegates in C# or agents in Eiffel, personally, I would never use observer. I mean, I will never program an observer again in my life. They promise. I mean, it's on video, commitment, and so on. There's really no reason to use observers if you have these mechanisms. So in the end, it's a language issue, in my opinion. So, but let's not look at the language first. Let's look at the abstractions. So the overall idea, not at an implementation level, but at a conceptual level, is to say that we are going to represent the entire scheme of a particular publish-subscribe situation by a table of triples. It doesn't need to be implemented that way. It can be lots of tables. It can be spread over many data structures. But conceptually, it's like this big hash table or a big table of triples, where we basically say for this event type, for this context, execute that operation. The event type is anything that we're interested in, for example, left mouse click. The context is not strictly necessary, but in practice it turns out to be very convenient to make it a standard component. It's in the end it's a Boolean condition. Okay? Concretely in a GUI situation, it's the kind of object for which an event type is interesting. Because for example, if you take left mouse click, it's very seldom that you want to write, if a left mouse click occurs, do this. Usually it is if a left mouse click occurs on that particular window or button or dialog, then do that. Okay? So that's why we want this extra level of qualification here. In a more general context, if we were not just talking about GUI, it would just be a Boolean expression, which determines whether the event is interesting or not. And then the action. Now, the interesting part, of course, is the action, because the first two are very easy to put into a data structure. We just take references or pointers to the corresponding objects, although you will see a bit more carefully how to represent event types. But certainly the contexts are very easy. The actions, well, if you're a C pro... Yeah.
It seems like the context is actually hard because the context has to take arguments, right? Otherwise it's not going to work.
Yeah. That's true.
So to me it seems the most difficult part.
No, actually, it's the at least in a GUI context, the arguments will show up in the action. We'll just pass the arguments to the action.
I need to evaluate whether I'm in the right place. I need to have the vertical and horizontal coordinates, which have to go to the context expression, right? So otherwise, how could I determine whether it's the right button?
No, but the context is the condition that determines whether you're interested in an event of a particular type or not. So my assumption is that this does not involve the arguments, but you're right, it could.
The arguments, and then it could still say, oh, this is not.
Of course, yeah.
But I thought that was what the context was for, because otherwise you're going to call everybody, even if they're not interested. So maybe I don't understand the context.
Yeah, I think, okay, it's the reason for the confusion. I'm responsible for the confusion, and the reason is that in describing this notion of context, I've said it's general, but I really have in mind the GUI example in which the context is very simple. It's the object, the visual object on which the event occurs. And my generalization was a bit careless. So I think in the general case, you're right. The arguments. So I would say maybe there's to address the issue simply, it's actually a table of 4 tuples where the fourth component is the arguments. Let's put it that way. And the arguments might be relevant for the context and for the action. So, for example, we'll say whenever there's a left click on the save button, the action should be save file, and so on. Whenever there's a left click on the map in some geographical application, apply the operation find station, and I'm still ignoring the arguments at this stage. So how do we do this? Well, in C and C++, we don't ask ourselves philosophical questions. We just use function pointers, and we just go home and pray to the Virgin Mary or whoever that what actually will be there at runtime will be a pointer to a function and not and to the right function. I mean, not necessarily not to a function that was deposed there by someone who doesn't wish us particularly good.
You want to have action being object, not function, because you want to have some attach some state to it,
which is exactly, of course,
interceptors and stuff.
Yeah.
Okay.
Yeah. So I'm not, just in case you were concerned, I'm not going to promote the function pointer approach in the rest of this talk. Yeah. So this, by the way, this particular topic, for those of you who have seen a little bit of the history of the friendly and sometimes not so friendly discussions between Sun and Microsoft 10 years ago about the evolution of Java and what became C#. This was actually one of the key points of the discussion. Microsoft wanted to add delegates into Java precisely for this kind of example, and Sun said this is not necessary. There's a nice white paper, a very interesting white paper at sun.com on the Java pages, a 1997 white paper, which explains why, in Sun's view, delegates are not necessary for Java and why you can do everything using essentially inner classes. And it's very interesting. I disagree with the conclusion. I think that, I believe personally that something like delegates or agents as they exist in IFO is pretty fundamental, but it's true that you can do it with inner classes. It's just a matter of elegance and reusability and extendability of the solution.
Did inner classes come after that discussion?
No, they were already there. But if you're interested in this kind...
The original Java version, right? They came in the second or third.
Really?
Yes.
Definitely in 97 they were there. Yeah. So if you're interested in this kind of issue, read that. It's very easy to find, or write me an email. I'll send you the URL. But it's still a very interesting technical discussion, whether you agree or disagree with the conclusion. So this was our example scenario. So just for fun, so this is where the police comes in to arrest me. This is how I understand it must be done in C#. Okay? Now, I must say that this is based on an analysis of the situation prior to the introduction of generics. Okay? And so I think things are must be a bit simpler now. And I pieced this from various parts of from various sources, because I didn't find, at least in the documentation, any place that actually says everything about how you address this issue. And it was very surprising. And then when I started reading C# books, I understood why it's not explained. It was not explained at that time, or they couldn't find a place where it had everything pieced together. Because my understanding is that most programmers who need this kind of thing are just going to buy one of these books or read one of these web pages and just copy paste the code and then adapt it to their own needs. But the full picture, if I understand it properly, is this. You have to introduce, on the publisher side, you have to introduce a class indeed to represent the arguments. Okay? So that in our case, it's 2 vertical coordinates. Then you have to introduce a new delegate type, because a delegate is a type which refers to the argument type. So this is the type of delegates that are able to handle that particular type of arguments. Okay? Then you have to declare an event type which refers to the delegate type that we have just declared. Then, now this kind of thing, honestly, between you and me, is not justified, and I have a proof of this. It's that whoever designed this realized that it was too hard to impose on normal human beings. By normal human beings, I mean Visual Basic programmers. So in Visual Basic, you don't have to do this. But in C# you do. So the reason is that internally, this event type, click, is really a list. And that list could be empty, could be void, could be null. Okay, so you have to wrap it into, and maybe it's not the case anymore. I haven't checked recently, I must admit. But you have to wrap it into this method to make sure that if the list is null, then we don't do anything and cause unpleasant consequences. We're still on the publisher side. And now we have set up our context, our environment, and we are ready to trigger an event. So when to trigger an event, we must do 2 things. We must create the arguments, so a new click Rx, and finally, we are ready to trigger the event. So that's what we need to do on the publisher side. And on the subscriber side, so we have to declare a type, my delegate, of the delegate type that we just described. And usually this is done together with the following step, in fact, through this instruction here, new click delegate. And as far as I know, maybe I'm wrong here, you'll correct me. As far as I know, this is the only place in the C# language where you can pass a method as argument to another method. Is this correct? Or am I wrong here? Because you have to pass your procedure, right? This is when you create a delegate. And in general, of course, most modern object-oriented languages and most modern languages, except for functional languages, do not allow you directly to pass a routine as argument to another routine. But here, of course, you need to pass it to the constructor. Yeah.
So if you want the correction,
yeah.
Since C# 2.0, the generated code is the same, but you don't need to create a new instance of the particular delegate. It's inferred. So you could just get a new click delegate and just say your function name. So it looks like you're passing the routine directly, but under the covers it's calling the constructor.
Okay, so I upload this with both hands, definitely. Yeah, good. Thanks for enlightening me. And then you have to add. So here could you pass the procedure directly here? Could you say my procedure or your procedure? Okay, that's great. So and then what you do here is that you add to the click list of the of the associated button, of the associated widget control, the delegate which has just been created. So as you know, this is a list insertion. Now, this is all right. If I may allow myself a small hint of dissent, did you hear any small hint of dissent in anything I said so far? Probably not, right? But if I just allow myself such a hint right now, what I don't like, I mean, it's all fundamentally right, but what I don't like is this need for the programmer to understand that deep down, this thing is a list. Okay? Because this is what this is, right? For every control and for every event type that is applicable to that control, like click, applicable to yes button, there's a list of all the subscribers. And I'd like to reason at a slightly higher level of abstraction. Why do I have to remember that it's a list rather than some other data structure? I just want to say, make the yes button aware of that particular delegate for that particular event type. So it's really a matter of style. And I must say actually that in the Eiffel Vision library, which provides the equivalent in the Eiffel context, there is actually also a list that to which you append directly. Well, the plus equal is an append to the list.
But maybe it is a set.
Maybe it's a set, yeah. I was just thinking that notation is equally applicable to a set, right?
Mm-hmm.
Well, still, I don't want to think of a set. I don't want to think that the button has a set or a list of...
If you write the specification of it, right? You would think of the specification as having a set, right? Because the set is a mathematical entity devoid of any issue of representation.
Well, actually, I don't know about your experience. In my experience, most of the time you don't really need a list, most of the time you just want to say, as in those triples, for that action and that control, for that event type and that control, do this. So it's very seldom, in my experience, that you actually want to have several. And in that case, you should have a notion of composite action. Sorry.
Kind of allows you the freedom to specify that you want only this event, only this handler to handle this event, or whether you want several handlers. Like it allows the client the opportunity to say that he's the only handler of that event. I guess that this is the semantics behind the plus and equals.
Right. Okay.
Well, equals is not allowed. So
okay, but theoretically speaking.
Sure. So, if we had your ideal way, how would you unsubscribe from the event? How would you say, I no longer want my procedure to be invoked when this event happens?
Well, that's coming, because I'm going to show my ideal way, of course.
Okay.
Are you objecting to the syntax? What if you were just for click.add or something like that?
Yeah, that's probably the way I would like to see it, right? Click, or maybe,
you're just objecting to this special syntax that was introduced for this particular...
I'm objecting in part to this because indeed I don't think there's a need for special syntax. Also, I don't think there's any need for a built-in notion of event type. An event type is just an object. It should be just so there's no reason the language should be polluted by this notion of sorry. Where is it? A public event. There's no need for this. It's just an object, and this public and this notion of an event type which is associated with a delegate. Why should people have to learn this as part of the language?
One of the goals was to make it clear that if you read some kind of class, signature, you could sort of tell immediately which ones were these events. And if it was just some random class name, you would not really know what you're supposed to do with it. So I think it was sort of a choice to make it easier to read.
But event types, events that they're called here, are just one important and useful abstraction among thousands.
Well, I
Yeah,
guess
this is an event type.
there's sort of multiple.
It's an event type associated with a certain delegate. So in the end, and this is perhaps also partly an answer to the to one of the previous questions, but perhaps the implicit, almost unconscious observation behind all this is the statement attributed, I think, to Alan Kay, that the simple should be easy, approximate quotation, the simple should be easy, the difficult should be doable. So here it's absolutely clear that the difficult is doable. Okay? My contention is more this about the first part. This is such a common situation that it should be just straightforward. Okay, so now here's the way I would like to see it, and the way we've built it in the event library that we provide. We, meaning in that case, students at ETH, or my group at ETH. So there's this notion of event, context, and action. We take them literally, and the solution is based on one class. So essentially there's one class. The whole mechanism is one class called event type with two operations. We call them features in IFO, specifically in this case routines, I think methods. So it's one class with two methods. Okay? And what's an event type? Well, it's the same abstraction that we've discussed. So a mouse click would be an example of event type, and here's the way it's going to work. Perhaps, let's see. Yeah, this is good enough. This is the whole scheme. So as the publisher, I have to describe an event type. Sorry. So I say, for example, I want mouse click, left mouse click. And it's going to be of type, event type, of tuple of integer and integer. So here, the outermost brackets correspond to genericity. Event type is a generic class. And this is the generic parameter, and it happens to be a tuple type. I'll explain tuples in a second. Let's also ignore this for a second. We just have an event type. Then, to trigger an event, I'm just going to use the procedure publish. So I say mouseclick.publish, and I pass the arguments as a tuple of two values, x position and y position. I think they were called h and v earlier. It's the same thing. On the subscriber side, on the other hand, all that I'm going to say is I'm interested in the mouse click event type for that particular button, and I want to subscribe my procedure. Okay? And of course, my procedure is a procedure. It's not an object. So I can only pass an object as argument. And the magic word here is agent, which corresponds to delegates. Okay? So it's very similar to what you were describing earlier with this syntactical simplification of passing the routine directly. Here we just prefix it with the keyword agent. And now, I think in the current state of C# with genericity, a solution like this is, if not exactly the same, it's very much possible. The big difference might be, well, for you could not, I don't think you have there are tuples yet in C#. So here you probably still need a class. And the once mechanism, you would have to use static. So what is once? It's simply a way to express that a certain routine is, as the name suggests, called just once. So the normal keyword here instead of once would be do. Normally, if you don't, for an ordinary routine, you'll have the keyword do. If instead of do, you write once, what it means is that the routine in question is executed just once, at most once, the first time it's called. And then if it's a function, as here, it returns a result, and every subsequent call does nothing but returns the same result. So it's a way to get global objects. Because here, first we want to create it only on demand. It's a kind of lazy creation. But once it's been created, we want, of course, the result to be always the same, because we would just want one it's a singleton. We would want just one instance of the class of mouseclick, of this particular event type. So basically, that's what there is to it. This is based on the tuple mechanism. I don't know if it's interesting to spend very much time on this notion. Let me just give you the basics. Tuple, it's really like a generic class, and it uses the same syntax with square brackets. The difference with a generic class is that in a generic class, the number of generic parameters is fixed, whereas here we can have tuple of nothing, tuple of A, tuple of AB, tuple of ABC. We can also have labeled tuples, and the overall inheritance structure is this. Tuple of A for any A inherits from tuple, tuple of AB inherits from tuple of A. So when I say tuple of A, I don't mean sequences of one element of type A. What it means is sequences of at least one element, of which the first is of type A, which makes this inheritance hierarchy meaningful, because then, of course, a tuple of AB is a tuple of A. So this is the way the inheritance mechanism works. Okay, so how do you go about it?
Just define a class tuple, and then you say inherit tuple A from tuple. That is, the names are all distinct if you have different kinds of numbers of arguments. So you can overload type names by number of type parameters. So you can define all this.
Okay. Okay, so I have to look more into it. Yeah.
The only thing that you can't do in C#. So I have these defined in my libraries. I have 9 of them defined. So you can have A, B, C up to 9.
Yeah, okay.
That's the difference. Is
yeah,
there's no way to specify
right, sure.
unknown number of
but
type
who's
arguments.
going to use more than 9?
Yeah. Okay. Yeah. Okay. Fine. So indeed you use genericity, but the number of parameters is fixed, and the basic difference between tuples and generic classes is indeed that for tuples you can have any number of parameters. By the way, we tend to use tuples quite a bit now that they are in the language. You never know when you this is a relatively recent addition, already 10 years, I think, but you never know when you introduce something into a language whether it's really useful, and also whether people will hesitate between using the new mechanism and the old mechanism, which is something that we absolutely try to avoid, right? To provoke this kind of confusion. But they seem to have found their right place into the language, so I can only say good things about tuples. Now this is agents. At the level of this presentation, they're very similar to C# delegates. There's some important differences, but they're not really the point of this particular presentation. So this is a particular and typical example of where you would use agents to integrate functions in this case. So you can say agent my function, but your function, as you can see, has 3 arguments, so we can also say agent your function with the first one open, and then the second one and the third one closed, meaning they've been fixed. And the routine itself. Sorry?
I have 2 arguments. So can I write when I write agent, can I actually give arguments like in C#?
Yeah.
Because your question mark is really saying there's a lambda expression where you get one argument, and I'll fill it in here, but can I explicitly
you can have what's known as inline agents, which are really like methods which are written in line. So it gives you the full power of lambda expressions. So you cannot use local variables of the enclosing routine. That is not permitted. You can use the fields, the methods and the fields of the class. But you cannot use the local variables of the enclosing routine. U and V would be, well, free variables. They would be something which come from the outside. Say, for example, I was talking about inline agents. So here they can be anything. They can be local variables. They can be anything. Yeah. So we talk about open arguments and closed arguments. The open arguments will be defined at the time of call of the agent. The closed arguments are defined at the time of definition of the agent. So this is the way the code would be written. Sorry, I messed up here. This is the way the code would be written for this particular example. This is the computation of the integral, and we use item to say evaluate f at position x, and this is a tuple because item needs, of course, to be general purpose, so it needs a tuple as its argument. So this is a bit an intermezzo, but coming back to the event library, this is the way it will work. So you declare the event type as a once function, I just said. Again, the publisher side. you create the event type object as part of the one function, and every time you need to trigger an event, you just publish it. I think it's harder to get more close to the crux of the problem than that. That's exactly what we want to do. We want to publish on the publisher side. More precisely on the publisher side, we want to define an event type. And to define an event type, we just say what the arguments are going to be. You cannot say anything less, right? You need to say what the argument types are. And to publish, again, you cannot say anything less. You have to give the arguments. But that's absolutely all that you have to say. And then, of course, there's a machinery behind this context event table, or maybe lots of tables, whatever the implementation is. But it doesn't matter from the client's viewpoint. And on the subscriber side, again, it's impossible to say less, because this is the fundamental information, the event type, the fact that you want to subscribe, and what you want to subscribe. So in the end, this is not so much a discussion about language. I hope you accept my proselytizing for Eiffel, because I think the mechanisms are a bit better. But it's really a discussion about architecture and about library design and making things as simple as they can be. Again, the simple should be easy and the difficult should be doable. So this we've seen. So to compare with the observer pattern, which I admit is a bit of an easy fight, with the observer pattern, we needed lots of classes. Anytime we had a particular kind of publisher or subscriber, we needed to inherit from subscriber or publisher respectively, which actually is pretty bad in languages where you don't have multiple inheritance. In Eiffel, it wouldn't matter too much because there is multiple inheritance. But often the publisher class is a model class, which already is there. So you need to add a new ancestor to it, and it's not that easy if you don't have full-fledged multiple inheritance. But all this goes away with the event library. You just reuse the existing routines directly as agents. You just subscribe them. You know, subscribe of agent this and that, this or that. Subscribe an existing routine. That's all you have to do. Yeah.
Again, in some cases, it's much like it's code looks better if you have state, right? And you can subscribe. Event handler can be an object instead of routine, right? When you just do when you want to like handle multiple events in single class instance, it's okay if you subscribe delegates or functions. But in a lot of cases, if you want, like for example, have chain of interceptors, and it's much easier like to have event handler be an object.
So let me do this.
How would you make the event handler?
Let me do this. I'm almost done. So let me get to my conclusion, my concluding slide, which is 2 or 3 slides down, and then we can have a discussion rather than answering right now. We can have lots of different models. There's a lot of flexibility. We can, in some cases, have direct subscription, no connection, no glue code at all. So there are lots of variants. Depending on, for example, this one is click.subscribe. So in that case, you subscribe to the event type. So this is the case that I mentioned earlier, which is not so common, in which you say, whenever a left click occurs, I want to do this. So then there's no context. But you can also have a click event type relative to a particular context. So the language constructs, the combination of language constructs that make this possible. In fact, I didn't show you, of course, absolutely everything. In particular, I didn't show you all the details of the implementation, although I showed you the essentials. So it's not that easy to remove any of these elements. It's really the combination that makes all this possible. Genericity, inheritance, polymorphism, dynamic binding, multiple inheritance, although it's not absolutely obvious in the part that I showed, but it helps. Constrained genericity, that is to say the ability to define a generic parameter in such a way that it must be a descendant, that the actual parameter must be a descendant of a given class, of a given type. Covariance helps, although of course it's always danger lurking in the back. Design by contract is kind of also there in the background. Once routines, which could be replaced by static methods, and tuples and agents, of course. The context of this work, just to advertise a little bit for the overall research project, which is kind of finished now, but which I think has uncovered a few interesting points. We started out with Karin Anu, one of my PhD students a few years ago, to see if we could take the standard design patterns and replace them by components, based on the assumption that I made earlier, that to reuse is better than to redo. And so this was part of it, if you like. We started from the observer pattern and looked to see if we could actually replace this pattern by an off-the-shelf solution. And it's typical of the part that we found to be the fully componentizable patterns, that is, those for which she was able to produce an equivalent reusable component, which is part of a library that we have now. So that's the main result there. For about half of the patterns, we were able to say, you don't need a pattern anymore. I'm talking about the patterns from the Gamma book. We took the classical ones. And for some of them, we were able to provide some library support with a wizard, but no library which is usable off the shelf, no component which is usable off the shelf. If you're interested in this, I think the best paper to read, the best introduction is probably this paper, which appeared in IEEE Computer a couple of years ago, applied to the visitor pattern. So it's kind of the same discussion that I've had here, applied not to observer but to visitor. And we published another one on factory as well. We've also done a little bit of work in a concurrent context. So there's a scoop version of the event library. And there's a little bit of theory, but I don't have time to do this, and it's too tentative anyway. So as a conclusion, the 5 lessons that this work suggests to me are that first, software architecture matters. It really makes a tremendous difference in the end, whether you are able to face a common situation like this one, a publish, subscribe scheme, and either, on the one hand, build something using, of course, good textbooks and advice from lots of places, but with a lot of manual work involved, and of course, debugging and difficulties of maintenance later on and so on, because you're accumulating code, or at the other alternative, use a very simple solution with all the advantages in terms of debuggability, of maintainability, and so on. Simplicity matters. It's not so popular anymore as in the times of Hoare and Wirth and others and Dijkstra, but these are lessons that I believe we should not forget. If we can make things simpler, it usually pays to make them simpler, because the benefits are going to affect many different programs, many different programmers. The key to design and programming is to find the right abstractions. And of course, in the case of object-oriented design, which is kind of the only game in town these days, it's the right object abstractions. So here we started with abstractions that were publisher and subscriber, which seem pretty natural and intuitive and attractive. But in fact, they turned out to be, as I hope you will agree, not the best possible abstractions for this particular job. And in the end, we settled on just one abstraction, namely event type. And it turns out that if we build this abstraction right, if we specify it properly, then it's enough. We don't need anything else, just event type. Fourth is this point. I mean, it's kind of dishonest of me to say that it's a lesson, because it was kind of a hypothesis before being a conclusion. It was one of my axioms, so to speak, one of my original assumptions. But I would claim that it's almost always better to reuse than to redo. All other considerations aside of, for example, performance, but if you can pull a solution or a partial solution off the shelf, as opposed to having to reprogram it the nth time, it's almost always better, especially in the long term when you take into account debugging, testing, and maintaining, extending. And finally, I would claim that language matters, and that the proper combination of language mechanisms really can help make a difference. Okay, that's what I had to say. Any more questions? Yeah.
I agree that reuse is better than redo, but in this particular example with the events and stuff, nowadays I get a nice UI and I draw my UI, and then I double click on the button and I say, oh, I want to react on a button click, and then it just write a little piece of code, and it generates all the event types or whatever the addition. So I don't even. Most programmers don't even know how it's really done. They don't even look at it. They never write it by hand. You just write the actual event code. Right? like in Visual Basic.
Right.
So in a sense, you could say that's even better because now I don't even have to write it, right? The language doesn't even matter. I have a better language of doing it, namely just generating it.
Yeah, I think you have a strong point. On the other hand, I mean, how does one maintain that code? Do you go back to the GUI to the environment to regenerate? Or do you have to maintain the generated code? If you have to maintain the generated code, I think the advantage that you're describing vanishes pretty quickly. This is always the problem with code generation schemes, like with model-driven stuff. The first time around, it's very fantastic. And for the demo and the talk at the conference, it's ideal. The real question is what happens when you wake up with a hangover.
So have you thought about it for Eiffel, like thinking about that kind of design?
But you know what, that is a very interesting question, because the answer is yes, but people don't use it that much. That is, there is a pretty good GUI builder in Eiffel called Eiffel Build, and typically people don't use it that much. The beginners use it because they're used to it. They come from Visual Basic or such, and so the idea that you would have to call library routines to build a GUI seems completely ridiculous to them. So Eiffel Build generates calls to the Eiffel Vision library, which is based on a kind of earlier scheme, earlier version of the scheme. So it's not as abstract as I would like it to be, but it's still reasonable. And the interface is the interface in the sense of the API is very, very easy to understand and to learn. You basically build your application control by control and box by box, and it has all the right defaults so that it positions the various controls right. So very quickly, people stop using the GUI builder and just edit the Eiffel Vision calls directly. Now, I don't know to what extent I can generalize this observation. Maybe it's because the builder is not good enough. That's also a possible explanation. But it doesn't seem in practice to be such a problem for people to use the API directly, and they seem to like the fine degree of control that they have by doing this. But let me return the question. Indeed, what happens when you want to change your stuff? And do you go back to the GUI builder? Do you go back to the generation scheme, or do people actually maintain the generated code?
Well, I think it's a big problem, right, in practice. So when people, but in C# they have partial classes. So in general, you don't have to touch the generated code. You should never have to. They should always go back to the GUI builder and do it. But you know, I'm not a big fan of that either, right? It's an interesting problem.
Yeah.
Because if you could make this feedback loop work well, where you can actually have a real good connection between a drawing tool and something more, then I guess it would be even better than just calling library routines. I just don't think we're there yet.
So one of the problems that actually comes up is you write the GUI. Initially, you use the GUI builder, like visual. You program it visually, and then you, for some reason, end up having, let's say, warnings because of another program that gives you warnings about the generated code that what you want to get rid of, and then you go and change that generated code, and then you cannot get back to the visual component anymore because it's not able to reproduce the visual effect. You change it by hand. At that point, you want to keep away from the warnings, so you're sort of forced to start editing and do it by hand the rest of the time. So some people, in order to avoid that, because it's hard to actually go and change this automatically generated code because it's so verbose, you actually do it by hand. I know a few people that actually, just because of that reason, don't use the visual designer. So there's sort of this interaction of a tool that causes you.
But so the interesting thing is the new thing, like the WPF, right? There it generates actually a declarative XML file. If you like to read XML, go ahead. Now it's completely separate. So there's a kind of an interpreter that interprets this description at runtime and visualizes it.
Right. But you're right. The key aspect is having full round trips. if you don't have full round trip, then it becomes quite questionable. There's, by the way, a question that I said I would answer later and I haven't yet. It's a question about unsubscribe. You asked it, right? So in fact, I think this is a much better interface for unsubscribe, because if I want to unsubscribe, this is precisely the case in which I don't want to have to bother with issues like, is this a list? Is this a set? If it's a list, is it first in, first? I mean, are the newest elements at the end, at the beginning, and so on? So I just want to say unsubscribe. So when I said that there are only two methods, of course, there are two fundamental methods, publish and subscribe, but there's unsubscribe, and then it just takes care of removing it wherever it is. Yeah.
But it's just syntax. I mean, whether you write the word publish or you do a plus equals, or I mean a subscriber, a plus equals, or an unsubscriber, a minus equals, the operation is exactly the same. If you don't know if it's a list or a set, you don't really know about order, you just know if you want to subscribe, you do the plus and an equals, and if you want to unsubscribe, you do a minus and an equals.
Okay.
I don't think most people even think about the fact that it's a list or a set.
Okay. Okay.
I had a comment. So, as you alluded to, C# 3.0, .NET 3.0 introduced a bunch of generic event types that sort of, instead of having 8 steps to create a publisher, you only have 2 now. So you have a generic event type, and then its type arguments are, they don't have tuple, but you can just do it yourself. But it'd be interesting to see a comparison between Eiffel and the generic event types that came about in 3.0.
I'd be quite happy to pursue this with you or someone else.
Sure, I could help you. I think that you'll find that at most you save 1 step in the Eiffel mechanism than you would in C#.
Okay, so that's great. Shows I was right all the time.
Yes, exactly. Shows they finally caught up to you.
Almost.
I think that's a nice conclusion for the talk, since we took so many questions in between. So let's thank the speaker for